Welcome everybody. In this part 2 of our study of nitric acid of ICSE class 10, we will be studying properties of nitric acid. Properties of nitric acid is divided into two parts. One is physical properties and the other is chemical properties. In physical property, we will be studying the color, odor, taste, nature, density and boiling point. You see, pure nitric acid is colorless, but the commonly available nitric acid in our laboratory as our laboratory reagent is brown in color. It has some reasons behind it. We will discuss it later. Odor, it has a suffocating odor. Acidic, it tastes sour, but remember not to taste it because it will harm your tongues. Nature, hygroscopic in nature and fumes in air. Hence, the bottle containing nitric acid should always be stoppered. Now, density, 98% nitric acid is 1.5 has a density of 1.54 gram per cc, whereas the commercial nitric acid has a density of 1.42 gram per cubic centimeter. Boiling point, of course it refers to pure nitric acid. It has a boiling point at 86 degrees Celsius and it melts at minus 42 degrees Celsius. Another point that is important in this regard is formation of azeotrope, that is constant boiling mixture in case of nitric acid. An aqueous solution of 68% nitric acid forms a constant boiling mixture. Now, in chemical properties, we have four subgroups. Now, the first one is stability, and the second one is its action as an acid, and that is acidic properties. In the third part, we will study its oxidizing agents, and in the fourth part, we will study chemical properties of nitric acid in the form of aqua regia. Okay, now let's proceed. Stability. Pure nitric acid is not very stable, but it can be stored in a brown colored stoppered bottle. Pure nitric acid decomposes in heat or in presence of sunlight to form nitrogen dioxide, water and oxygen. Okay, now we will study acidic properties, part 2 of our study. Nitric acid in an aqueous solution forms hydronium ion, and this is clearly shown by this equation. Here, nitric acid in aqueous solution is decomposing to form H plus and NO3 minus ion. This H plus combines with another water molecule to form H3O plus. Okay, now acidic property can also be shown by using litmus. It turns blue litmus red, methyl orange to pink, and phenolphthalein remains colorless. These are the distinctive properties of these indicators. So from this we can also identify it as an acid. Now, reaction with an alkali. Acids have the inherent property to react with an alkali, and alkalis can be of different types. We have in this table potassium oxide, cupric oxide, zinc oxide, sodium hydroxide, ferric hydroxide and magnesium hydroxide. So, nitric acid reacts with all of them. To form corresponding salt and water. Here, as it is nitric acid, so it will form nitrate salt. We have potassium nitrate, then we have copper nitrate, then zinc nitrate, then sodium nitrate, ferric nitrate and magnesium nitrate. So these are the salts that form. So what is the key word? We must remember that an acid will react with a base to form a salt and water. Okay, now reaction with carbonates and bicarbonates. We have here in this chart a list of carbonates and bicarbonates. We have calcium carbonate, then we have sodium hydrogen carbonate or sodium bicarbonate, and then we have sodium carbonate in the third place. After that we have copper carbonate in the fourth place. So this is all we have. Now in regard to reaction with carbonates, it is similar to reaction with alkalis, but the difference is that in alkali we had salt and water. Here we will have salt and water along with carbon dioxide. So this is extra. With carbonates and bicarbonates, we have carbon dioxide as an extra gift, I can say, along with salt and water. Next, let us proceed to see its reactions with metallic sulfides and bisulfides. These reactions are similar to those of carbonates and bicarbonates. Only in place of carbon we have sulfur. So we have potassium sulfate, copper sulfite and calcium hydrogen sulfide. All of these are reacting with nitric acid to form corresponding nitrate salts, water and sulfur dioxide gas. So in case of carbonates, on the top of this page you can see we have carbon dioxide, and in case of sulfides you can see we have sulfur dioxide. So this is only the difference. So I think it's easy to understand. I hope you will manage. Let's proceed to our third part of learning today, is oxidizing properties of nitric acid. Nitric acid is a very good oxidizing agent. It oxidizes both metals and non-metals. What is the cause? The main cause for nitric acid for oxidizing is that it can produce nascent oxygen, and this nascent oxygen reacts. Okay, now the reactions. As you can see, we have reactions with non-metals. It's very important to note that it reacts with carbon and sulfur to produce carbon dioxide and sulfuric acid. Along with it is producing water and nitric acid. One important point that I would like to point here, that why in case of sulfur we have sulfuric acid and not in case of carbon we are not having carbonic acid. Actually we will be having carbonic acids, but carbonic acid is unstable. It decomposes to form carbon dioxide and water again. So we have written it that it reacts to form carbon dioxide and water. Similarly, in case of sulfur, we could have said that sulfur reacts to form sulfur trioxide and water. That sulfur trioxide will combine with water to form sulfuric acid. So these reactions are similar in a way. Okay. Now action with metals. Nitric acid reacts with all metals except gold and platinum. Except gold and platinum. You have to remember it. There are two types of reactions that we need to put in our mind. One is with cold and dilute nitric acids. So these cold and dilute nitric acid oxidizes metals to their nitrates and liberate nitric oxide. So this is the point to note. So here we have nitric oxide. Nitric acid is reacting with copper, zinc and iron, and there is one point to note. We have copper that is below hydrogen in the metal activity series, but still it is reacting with nitric acid, and the cause is that nitric acid has oxidizing property. So by only this property nitric acid can react with copper. Other reactions with zinc and iron follow the similar pathway. Now next part, concentrated nitric acid. We are using hot dilute nitric acid. We can use concentrated nitric acid in cold condition, or we can use hot and dilute nitric acid. So these are the two conditions. So if you use these conditions, then you will have nitrogen dioxide. With dilute nitric acid in cold condition we had nitric oxides, and with hot and dilute nitric acid we have nitrogen dioxide. Other products are the same, a salt, water and nitrogen dioxide. Thank you. And next one is that metals like iron, aluminium, cobalt and nickel, they become passive when they are treated with pure concentrated nitric acid. It is due to formation of a very thin layer of insoluble metallic oxide that stops the reaction. So this is the cause, and this passivity can be removed by just rubbing off the surface that has formed. Okay. Now there is a special note that is there in a book. Dilute nitric acid is generally considered as a typical acid except for its reaction with metals, since it does not liberate hydrogen. It is a powerful oxidizing agent, and the nascent oxygen formed oxidizes the hydrogen to water, so we don't have hydrogen. Of course, we can have very dilute nitric acid, about 1%, and make it react with magnesium to get hydrogen. We can make it react with manganese to get it hydrogen also. So from the academic interest, we can study it. Now the last part 4 of our discussion is reaction of nitric acid as aqua regia. We know, as we have studied hydrochloric acid earlier, that nitric acid, one part of nitric acid reacts with 3 parts of hydrochloric acid to form nitrosyl chloride, water and nascent chlorine. This nascent chlorine is responsible for reaction of aqua regia with platinum and gold to form platinum 4 chloride, or we can call platinum tetrachloride also, and gold 3 chloride or gold trichloride. These salts are soluble in water. So this was all about the reactions of nitric acid. Thank you very much. We have part 3 left to conclude our discussion. Please do come again to watch it. Thank you very much.